Okay, Newton's laws of motion. So Newton's first law is referring to a force and how it acts on an object. First of all, you need to know that a force is a push or a pull. And when you combine forces, you're talking about more than one force acting on an object at the same time. Force is measured in newtons. Now, the definition of a newton is a force that causes an object with a mass of 1 kilogram to accelerate at 1 meter per second. Net force is referring to the combination of all forces acting on an object. So Newton's first law is also called the law of inertia, and it states that an object at rest stays at rest and an object in motion stays in motion, which would be true if there were no outside forces acting on an object. But the reality is that here on planet Earth, there are always outside forces acting on an object, primarily the force of friction. There's three types of friction. There's static friction, sliding friction, and rolling friction. With static friction, atoms on a surface stick or weld together. You experience that when you step your feet across a carpet, for example. With sliding friction, that's due to the roughness of a surface and it slows an object down. You've been sledding down a hill, you have experienced sliding friction. And rolling friction, which occurs between the ground and the object touching the ground. Gravity is a major factor in Newton's second law. And the force of gravity exists between any two objects that have mass, and it pulls the objects towards each other. Now, the force of gravity depends on an object's mass and their distance from each other. So, for example, the moon exerts a force of gravity on planet Earth, but planet Earth is much larger than the moon, so the Earth itself doesn't really get pulled towards the moon. However, on Earth, our water is pulled towards the moon, and essentially that is what creates tides. Mass and weight are also affected by gravity. Remember, mass shows the quantity or the amount of matter in an object, but weight is showing the size of gravity. It's showing how strong gravity's pull is on an object. So weight is defined as the measure of the force of gravity acting on your body, which means that the force of gravity changes depending on an object's mass and its distance. So if you think about that, your weight, okay, if you were to step on a scale and weigh yourself, that would actually change. It would change if you were on an airplane above planet Earth. It would change if you were on the moon. It would change if you were even farther away. So the actual weight changes, although the amount of matter that makes up an object does not. Gravitational force is called gravitational force affects the acceleration of an object. So acceleration due to gravity, if we were to just drop an object, the only thing acting on it was gravity, it would travel downward. We're talking about planet Earth. It would travel downward at an acceleration of 9.8 meters per second. So Newton's second law states an object acted upon by a force will accelerate in the direction of the force. And when we talked about motion and momentum, we talked about ways an object can move. And so we're just going to review them here. Okay, an object can speed up, which really means that the force acting on the object and its direction of motion are in the same direction. So if there's a small kid in front of you and they're walking down the hallway and you give them a push, which you shouldn't do because it's not nice, but if you did, they're going to accelerate in the direction that they were already traveling. Slowing down, force and motion are in opposite directions. Thinking about football, okay, two people are running towards each other. If they collide, right, they'd be moving in opposite directions and they will end up slowing down. Turning, even when traveling in a straight line, the force of gravity causes a downward motion. So when you throw a ball, it doesn't just travel straight out forever. It eventually curves downward towards Earth's surface. And circular motion. Okay, this force called centripetal force keeps the object on a continuous path. You'll talk more about centripetal force as you get into high school. So how do we calculate acceleration? Acceleration is calculated by the, or is determined force of an object equals mass times acceleration. So acceleration is equal to the force divided by mass. It's the same formula, you just move around your variables. So F stands for the total force measured in newtons. M stands for mass of the object, and that is in kilograms. And acceleration is measured in meters per second squared. And it's going to be important when you do acceleration calculations. Make sure you check your units and make sure that you're using newtons and kilograms and meters per second squared. Newton's third law states that for every action there is an equal and opposite reaction. The action and reaction forces, they don't just cancel out, but they act on slightly different objects. In weightlessness, gravity is still acting on an astronaut. It's almost 90% of what it is on Earth's surface. Okay, but remember that weight is in reference to an object pushing up on you, and in space you're actually continuously falling. So because there's no object pushing back up on you, because there's no object pushing back up on you, you feel weight. And measuring weight, when you step on a scale, it's really measuring how much force it needs to push up on you.